Welcome back, guys, for another weekly breakdown. So we'll get right into it. So on Monday, you're going over your second part of the cardiovascular tools note. I'm actually going to go over both 1 and 2 after I kind of give you your weekly breakdown. So Tuesday's your Unit 2 test. Make sure you're prepared for that. It's going to come out Monday at 8 a.m. You have until Thursday to complete the test. So again, Monday it's coming out early for the people who are ahead of time. And then it's going to be up until Thursday, 8 a.m. You have to complete it. So that's pretty straightforward. Then Wednesday and Thursday, you're going to go into the respiratory tools note. It's very similar to what we're doing with cardiovascular tools here. We're going to look at the anatomy of the respiratory tract and then continue on with some tools that are used to assess it and as well treat problems with them. And then Friday is your regular discussion day, so nothing different there. A couple problems with the papers, not a lot. I had a lot of you guys not submit them, so please pay attention to this and pay attention to the calendar and the dashboard on Jupyter. Every assignment has its date listed beside it when it's due, and the calendar has it written out well in advance as well when you're supposed to work on it. So pay attention to that stuff. Okay, so that's your weekly breakdown. It's a pretty straightforward week. You guys are getting on the swing of these online things. So we're just going to get into the cardiovascular tools. So first up, we have the pretty simple one in blood pressure. We talked about blood pressure readings when we talked about the cardiovascular diseases. So when you have high blood pressure or a high heart rate, it's a really good indicator that you actually have a cardiovascular disease. It's not always 100%, but it's a really good indicator. Strong correlation would be another term there to use. So looking at the two types of blood pressure gauges that we talked about, there was the stethoscope and sphygmometer. So that's the one where you actually just link up the cuff, you inflate it, you have the stethoscope, you slide it right under the brachial artery here. So the stethoscope's resting there, the person's relaxed. If they're really nervous or they're like not sitting in a nice relaxed way, that's going to affect the blood pressure as it's changing the position of the arm and the stress and the blood flow going through the arm. So you always want to have them seated, arm rested, preferably on the table, and then stethoscope to the brachial artery. And then what you're going to do is you're locking off blood flow there. So as you inflate that cuff, you watch the gauge go up. Usually you pump it to around 180. So the idea is that when you cut off blood supply, that would be the same amount as the maximal pressure that the artery could withstand. So you pump it up usually around 160, 180. 180 is pretty tight. I should double back on that. So pump it up to around 160. Then you start to let the air go out. And what you're going to do with that stethoscope on the brachial artery is you're listening for when the blood starts to pump again. And that's going to be your systolic or top pressure, the highest pressure that the artery withstands. Then you're going to see it go down. There's two things you can do when you're using the stethoscope and sphygmometer. You can visually watch the gauge. When you get to your two readings, you'll notice it actually kind of does a little kickback. So that's your indicator. Or you can listen for the sounds of blood pumping. And then you go, and when you hear the blood stop pumping, that's your diastolic pressure, the bottom one, the minimum amount of pressure that's on the artery at any given time. So that's the manual way of doing it. There's obviously benefits to the manual. If you have someone who's very trained, they're going to get a lot of accurate results as long as the equipment's properly calibrated. Someone who's not properly trained, though, you can get a lot of user error, which is where the electronic, it eliminates user error, but it all relies on being properly calibrated, right? So if it's not calibrated right, it's going to give everybody the wrong results. And in general, these things kind of have to use general diagnostics, whereas someone who's trained might be a little more accurate because they know what they're looking for. So next up is heart rate monitors. Pretty simplistically, how many times is your heart building up and pumping the blood? So you should have looked at the anatomy of the heart and looked and seen that you have your two atria and then your two ventricles on the bottom. So then it's going to go from atria to ventricle, ventricle to ventricle, out the atria. So what happens there as the heart's creating pumps within two chambers, right? So you have the one chamber on the right side and the other on the left side. And as they start to go through, they're pumping deoxygenated blood to the lungs to where it become oxygenated, and oxygenated blood out to the muscles so it can be utilized. The less often that your heart beats to do so is an indication of how efficient it is. So someone with a lower heart rate at rest or during exercise means their cardiovascular system's working more efficiently than someone else. So they're getting oxygen and blood where it needs to go. They have either maybe a really high stroke volume, so when they build up, they shoot out a lot of blood, or they have a high VO2 max, meaning they can clear lactic acid and just regularly maintain that. No buildup of lactic acid also means that your body's keeping the oxygen flowing and not dealing with any of that. Next up is dialysis. So this is actually a role performed by our kidneys naturally. If your kidneys start to fail or become unhealthy and can't do the job, maybe you have to give one or one dies off, whatever it is. Some of them, they weaken in pairs as well. So over time, as you get older, they're going to start to become weaker. You may need dialysis. So what the kidneys naturally do is they filter out toxins and then we excrete them. So as the kidneys can't perform that function, we get a machine to perform that function instead. So instead of your kidneys filtering the blood, you get hooked up to a machine, it filters the blood and recirculates it. AEDs and ICDs. So the main word here is in the D for defibrillator. So the difference between them is automatic external defibrillator. So this is what you think of in movies, or if you've ever seen them around at the rink. They're the shock paddles, right? Now in the movies, the doctor rubs them together. In the rinks, it's actually like an automated one that's gonna walk you through it. A lot of people think you have to be CPR certified to use an AED. That is not true. AEDs give guidance on how to be used either on an adult or a baby. That being said, it's obviously better if you have someone who's trained and is more comfortable with it, but like I said, it's gonna walk you through the process, and in theory, anybody can use them. If someone's dead, you're not going to do anything bad to them other than maybe wake them up again, restart the heart. And that's what these guys are doing, right? Where you talked about the pulsation of the heart, your body converts the electrical stimuluses from your nervous system into contractions. Those contractions are the pumping of blood. So the AED, again, someone's unconscious, potentially dead, use the AED to restart their heart. And then the ICD, so internal cardioverter defibrillator. The main one I want you to take away from is it's internal and then external. So the ICD, we'll talk about it with pacemakers in a second, but it's essentially like a fail-safe pacemaker, right? If the heart stops working, then the ICD picks up on that and it restarts it. It gives it a very big shock. Whereas the pacemaker is going to regulate the flow of blood. Now there's two ways it can do it. There's a single lead, so that meaning there's only one attached on the ventricle, or there might be a double lead, meaning it's attached on the atrium and the ventricle on the right side, okay? So single lead, just on the ventricle, double lead, atrium and ventricle. So what those guys are doing is, again, they're regulating the pulse of the heart specifically on one side. Now that's only if you have problems with one side. If you have a very inefficient heart and the chambers don't work very fluently, the valves don't work, you might need CRT. So that's cardiac resynchronization therapy. So what you're doing there is it's essentially a triple lead. So if we start with the blood in the right atrium, right atrium, right ventricle, left atria. You have single leads and double leads for when you get to those other parts if it's weakened. You're never going to need one that goes in the right atria just because it's the starting point, right? So from there on, you might have the need for those triple leads. So again, one in each of the chambers going forward to help it contract as a whole. You don't need the initial one because where it enters from. Next up, we have valve replacement. So like I just mentioned, amongst those different chambers, each one is connected by a valve that prevents blood from flowing backwards, which is regurgitation. It also makes sure that it's pumped efficiently. So there's two different ways that your blood, three. We just mentioned regurgitation, so the two other ones would be artesia and stenosis. There's a slight difference between them, but again, they come back to valve defaults where the body can't pump between each chamber, each atrium to ventricle. Atrium and a ventricle combined is a chamber. So artesia is something you're born with. So it's a defect. It can happen in a variety of ways where the valve just fluently won't transfer the blood, either meaning there's backflow, so it comes forward, it's too thick, so it's too narrow. And then there's stenosis. So this is when it's overexerted. Those two valves are going to essentially thicken. So if naturally between one chamber to the next chamber you have the valve and it opens up that much, well, if they're thickened, right, they get worn up, built up. We talked about it with cardiomyopathy, the tissue gets built up, a scar tissue. Now that hole, again, if it's naturally like this, when it contracts and relaxes, they have a pretty wide bridge. But if these guys get thicker, that makes the gap down the middle a lot thinner. And that can lead to damages, a specific form of anemia actually. So where the red blood cells are being squished through so violently that they rupture. Okay, next up you have the left ventricular assistance device. So what this is essentially you have, I'm going to draw the heart in red here. So you have your atrium and your ventricle. You may have a problem with the flow of going from here to here. So what they'll do is essentially insert a tube that bypasses the use of that ventricle. No more use for it. They also will typically pair it with some form of regulatory device to make sure it contracts in a systematic way, because it is modified, right? So that's all the LVAD is. It's pretty simple, right? It's just a little pipe that bypasses the one ventricle. PCIs, percutaneous coronary interventions. So we talked about it with arteriosclerosis and coronary artery disease. So in general, if you have arteriosclerosis or atherosclerosis, that means your artery is getting narrowed due to the buildup of plaque. So if your blood's got to pass through, the more plaque buildup you have, the more pressure on your on your arteries, leading to increased blood pressure. Now, where coronary artery disease comes in is if that problem happens within an artery found in the heart. So if they detect that you have a significant buildup of plaque in the heart, you'll get a PCI. They'll remove any of that buildup so that the heart pumps fluently and you avoid coronary artery disease. Okay, and then lastly, donation and transplants. So donation is, blood donation is a predominant one. It also really ties into transplants, but we'll talk about the slight difference there. So blood donation all revolves around what type of blood you have. So there's 4 types. There's type A, type B, type AB, and type O. Type A have antibodies called type A antibodies present in their blood, but they don't have the B ones. Oppositely, type B, they have B, no A. Type AB, they have both, and type O has neither. So the way it works is that if your body naturally has an antibody present, you can't take blood from someone with an unnatural antibody. So meaning someone who's type O can take whatever. They don't have any antibodies present. Someone who's type AB needs specifically type AB, and then someone who is type A couldn't take type B or type AB because they would be rejecting the type A's. I used type B there. Might have mixed it up, but you get the idea, right? If you've only got one of the antibodies present, you have to take another form that doesn't have the opposite antibody. So how does that tie into transplants? So looking at transplants, it's an actual organ, right? Not just this blood that's going to be circulated through the body. It's more like a tool rather than the lubricant of blood. So the blood type really does matter with the organ. So it's a very big predictor in whether someone's going to match that organ or not. But there's a ton of other factors that you have to consider, predominantly age and health. For example, you wouldn't give an old person's heart to a younger individual. Even though they might have the same blood type, it's not going to be able to handle what it's supposed to do, right? You have to consider those factors. Every type of cell ages as you get older. They have expectancies. So that's it for this week, guys. Again, I didn't really review the anatomy of the heart here, so that's something I really want you to do on your own. We've gone over some videos. I'm putting up those games. If you guys want any worksheets or anything like that, send me a message. I can send you some. But for the most part, I really do think those games are better than a worksheet. They're more engaging, and they're the same facts. Okay? The few things, I need you to know the 4 chambers, so where are the 2 atria, the 2 ventricles. I need you to know where the valves are, and I need you to be able to identify these three things: the pulmonary artery, the aorta, and the pulmonary vein, okay? So if you can identify, again, the chambers, the valves, and those three things I just mentioned, aorta, vein, or both pulmonary artery and pulmonary vein, you're going to be good in terms of the anatomy of the heart. So that's it for this week, guys, and I'll talk to you next week.